Namaste, good day to all my students. In this lecture, I will explain about Module 5, fourth topic, graph coloring, which is solving using backward approach, or sometimes we will call it as backtracking approach. Now, before going to graph coloring, I will take one example and I will explain this one so that you will clearly understand what is meant by graph coloring. Actually, this is not the real graph coloring. For understanding, I will take this example and I will explain. And it is somewhat similar like this one, right? Now, this example you see here, there is a graph. It having three vertices. The first vertex is x1, second vertex is x2, third vertex is x3. They may give as A, B, C, the vertex numbers, or 1, 2, 3. This particular state space tree is drawn based upon x1, x2, x3. That is why I took as x1, x2, x3. Now the question here is, we have to color these particular vertices, right? X1 vertex, X2 vertex, and X3 vertex. For that one, that is the graph coloring. There, I took some examples, or I took some of the colors. First color is red. For red, I given number as 1. Second color I took as green. I given the number as 2. Third I took as yellow. I given the number as 3. See here, first x1 I can color using red, then x2 I can color using green, x3 I can color using yellow. So many possibilities is there. Another one possibility, x1 I can color using green, x2 I can do color using yellow, x3 I can do color using red. Otherwise, another possibility, x1 I can do using yellow, x2 I can do using red, x3 I can do using green. This all the things I can say like this. This everything I have to show using a state space tree, right? Now I will explain how to draw this state space tree. Like every state space tree, the initial stage we will call it as 0 or root node, like this here also. This is the initial stage. For every state space tree we have to draw, right? I hope it's clear. First I will consider for x1 after that, this line, and this is x1. x1, which color I can give? One color I can give as red. That's why x1 is equal to 1. x1 is this node, equal to 1 means I can give the red color. Only red color I can give? No. In some cases I can give green, or some cases I can give yellow. That is why next option I am taking, same line have to come here. x1 I can give 2 also. 2 means I can give as green. In other option, x1 I can give 3 also. 3 means I can give as yellow. Right? That only previously I explained here. Now x1 I can give 3 colors. What about x2? Same. There you can see here, x1 we are taking 3 connections, because from x1 only x2 is connected. That's why x2, which of the colors I can give? Same. Red I can give, otherwise I can give green, otherwise yellow. That's why x2 is equal to 1. That means x2 I can give as red. Otherwise x2 I can give as 2. Here if you want you can write x2 is equal to 2. Due to the space it is not written, do not confused. Or I can give as x2 is equal to 3. That means yellow I can give. Correct? If see here x1 is 1, that means x1 is red, x2 I can use 3 colors. Am I right? There's no way I can do it. That's why it is showing x1 is red, x2 I can make as red, green, yellow. Now x1 is green, then again x2 I can make it as red, green, yellow. That only this is showing. If x1 is yellow, then x2 I can draw as red, green, and yellow. Here also if you want you can write x2 is equal to 1, x2 is equal to 2, x2 is equal to 3. Here also. right? Now you see here, x1 is red. In this case, you see x1 is red because 1 is red. x2 also red. Then x3, which are the options? Again, 3 options. x3, this one, I can make it as red, or I can make it as green, or I can make it as yellow. See here, x1 is red, x2 is green because x2 is equal to 2. Then what are the options for x3? x3 again 3 options. x3 I can make it as red, x3 I can make it as green, x3 I can make it as yellow, right? Next, one more option here. x2 I made as 3, that means yellow. I will start with the root. x1 is red, x2 is yellow, then x3, which of the colors I can give? Again, red, green and yellow. That's why 3 bubbles it is written. Like that, this one also, right? I hope it's clear how to draw this one. Actually, this is not the actual graph coloring. Just one example. Normally, they will ask for M color optimization problem. This is graph coloring only. This is not the real graph coloring what they are expecting. They are expecting always M coloring optimization, right? That one we will go. These are the theory part. I will explain later. I will come and read this theory and I will explain what is the meaning of this theory part, what it is written here, point by point, right? Now I will take one graph. See this particular graph. Do not worry about this number 1, 2, 3. That is the answer. It is written here. Actually, you have to see the names which is given for the vertices. A, B, C, D, E. Right? Here, first I am going to explain graph coloring using M color decision problem. Two are there, very important. M color decision problem and M color optimization problem. Normally they will expect this one. Decision problem I will explain. See how many vertices are there? 1, 2, 3, 4, 5 vertices. What M color decision problem is there? If you have 5 vertices, how many colors you should use? That's the question. How to find out is very simple. See each vertices and how many edges are going, you have to check for each vertex, and which vertex have maximum number of edges going, you have to find. For here 3 is going, correct? For C, A 3 is going, B 3 is going or 3 is coming. For E also same. For D it is only 2, this one and this one. The maximum it is 3. In other words, we will call it as degree. This is degree of A, it is 3. Maximum degree plus 1 color we want. That is a maximum amount. Degree is 3. 3 plus 1 is 4 color. Easily we can fill this particular graph. Right? 4 color. Easily I can do this graph. This is not using that one. For example, 4 colors. I will take 1, 2, 3, 4. Correct? 1, 2, 3, 4. And one more concept here it is there. For the adjacent vertices, same color should not use. I will repeat. For the adjacent vertices, same color I should not use. Right? I will take here example as 1. I will make it as red color. 1, 2, 3, 4. 4 colors I can use here. Right? 4 colors. I will increase the font size so that it will be clear for your people. Still I will increase. Yeah. 1, 2, 3, 4. 4 colors I have to fill. That means A I should fill using one color, B I should fill using another color, or some way. Why the rule I will explain again. Adjacent vertices should not have the same color. Who is adjacent? There is a edge is going from A to B. Then for A, B is adjacent. For B, A is adjacent. A to D, there is no edge. That's why for D, A is not adjacent. For A, D is not adjacent. I hope it's clear what is adjacent. Edge is going, it is adjacent. Now already I told that there are 3 edges are going. That's why degree is 3. Then maximum number of colors we can use is 4. D plus 1. Now I will explain this one. This 1, 2, 3, what it is written is different. Do not confuse. For A, I will give 1. For B, I can't give 1. Why? Because it is adjacent. I should use other color. I will use 2 here. And for E, I can't use 2 as well as 1. Why? For B, I given as 2. For A, I given as 1. That is why I can't use. Correct? That's why I will use 3. Correct. For D, I can use if you want, I can use 4, or if I want, I can use 2. Why? 2 is not connected here. That's why I can use 2. I can use 4. A lot of combinations I can use. For example, I am using 2 here. For C, I can use either 3 I can use because there is no connection to 3. I can't use 1, I can't use 2, or I can use 4. That is the concept here. But what that is called it as, that one we will call it as M coloring decision problem. Now why it is decision problem, I will explain here. Why it is calling as decision problem. How it is going to solve this, I will ask first. Decision means true or false. That is decision. Can I fill first color to A? That is a way. If it is true, yes. If it is false, no. Can I fill first color to B? No, because first color it is already given to A. Like that answer will come, right? That is the way we are going to solve this one. That is called it as decision problem. Now the real problem we have to do M color optimization problem. Based upon the optimization, we do not want 4 colors. We only want 3 color. 1, 2, 3. Again, I given the name as one is red, second is green, and third is yellow. That only it is written here properly. See here, first color red I given to A, second color green I given to B because red I can't due to the adjacent. For E, I can't give 1 and 2. That's why other color I given 3, yellow. D, I can give red because there is no adjacency here. That's why D I given as red here. For E, I can't give as red as well as I can't give as green. That's why I given as 3. That is nothing but yellow. Right? This is the way we have to solve. But they are not expecting that you have to just put this number. You have to draw the state space tree. Clear? Now I will explain the theory. Then I will take one example and show the state space tree for the M coloring optimization problem. Right? Now I will explain the theoretical part. Let G be a graph. What graph it is given? It is assumed that it is G. N be a given positive integer. What is M? M is equal to 3 means it is a positive number. In the previous case, M is equal to 4. Right? That particular number, that graph chromatic number we will call. That chromatic number. 3 is the chromatic number. That means 3 colors I can use. I can use any color. For just example, I took 3 colors. Whichever the color you like, you can use. Right? That is called as chromatic number. Which color you are using, the set of colors is called as chromatic number. That's why positive integer, it should be a positive number. We want to discover whether the node of G can be colored in such a way that no 2 adjacent nodes, already I told, no 2 adjacent nodes have the same color, yet only M colors are used. You only have to use the M color. 3 means 3 color, but the 2 adjacent nodes should not use the same color. That is the meaning of this one. That one we will call it as M-colorability decision problem. And the maximum number of color we can use as D plus 1. What is D? Degree plus 1. Degree is 3 plus 1, 4. Which is the largest degree we have to find out. Maybe 3 is the largest, you have to use 3. Maybe 4 is the largest, you have to use 4 plus 1, 5, and so on. Now, M-colorability optimization, just know what I explained. There we have to use the smallest integer M. Smallest integer, the chromatic number will be smaller so that it have to be satisfied. That is called it as M-colorability optimization problem. Just know what I explained. M is equal to 3, right? Now I will go and explain one example. This is the real example for optimization problem. Take one graph. 1, 2, 3, 4, right? Here I should color. Optimization, I don't want 4, but based upon the rule, if you are seeing also, there are degrees too, that's why it is 3. For minimum, I want 3 colors, it is taken here, right? 3 colors it is using. One is red, second one is green, and third is yellow. Based upon the first example, what I explained, it is drawn. But that is different. This is entirely different. Please understand clearly. Then only you will clearly understand how it can be drawn. Right. Now you see x1. Initially, we have to take one node as 0th node. For every state space tree, we will take. And first node, I am going to consider first node 1. Actually, if you want to give x1, you can write. But in the question, maybe they will give us 1, 2, 3. For this one can be x1, this can be x2, this is x3 and x4. See here, this is x1. That's why this we will write in the edge part only that particular one. X1 is equal to 1. That means x1 I am assigning here inside as red color. Then if it is red color for 1, for 2 and 4 I can't use red color because it is adjacent. For 3 I can use red color. You understand here? X1 I use as 1. For x2 I can't use as color as red. Which of the colors x2 I can use? X2 is this one. I can use green and yellow. X2, 2 and 3. What is 2? Green. X2, what is 3? It is yellow. Clear? That is my first option. X1 instead of red, can I use green? Yes, I can use. X1 is equal to 2. That is why I am using green. If X1 is 2 is using, then X2 I can't use as 2, right? Either I have to use as red or I have to use as yellow. That you can see here. X2 I am going to use as red. X2 is equal to 1 can write. X2 is equal to 3 can use, right? Because it is not written X2. If you want, you can write. If you are not writing also, no problem. But it is X2 only. Because first they are written here as X2. That's why they are not continued with X2. That is the second option. Third, for the first one, I can use as yellow. Then 2, I should not use as yellow. I should use red and green. X1 is 3, then I can use as 1 and 2. That means red and green I can use for second one. I hope it's clear. That is X2. That only it is showing here. Correct? Now in the next level you have to see we are writing for X3. That means we are writing for the third one. Right? I am using X1 as red here. X2 as green. X3 I can't use as green because this is connected. But which of the other colors I can use? I can use red and yellow. It's correct? That you can see. X3 I can use as 1 and 3. I hope it's clear. Correct? Now I will go with X4 also in this particular case. X4 I can't use as red. Why? 1 I am using as red in this particular case. This always you have to see from root node to leaf node, which are the colors it is used. Then only clearly you can do it, right? Now X1 I am using as red. That's why 4 I can't use as red. 3, which color I am using here? 3 I can use red. That means here also I can't use red. For 4, which are the options I can do? 2 and 3. Either I can use green or yellow. That is why X4 I am using as 2 and 3. Here you see again here, this one. X1 I am using as red. That's why X4 I can't use as red here. And X2 I am using as green. That is why green I can use here. X3 I am using as 3. That is yellow. That is here for X4 in this particular path, there is only one option I have. It is green. Because here it is red. Here it is green. Here it is yellow. That is why green only I can use. I will explain this part also. See here, X1 is equal to 1. That means X1 I am using red. X2 I am using yellow. X3, which are the options I can use? Remaining 2. Which one? 1 and 2. Red and green I can use. Right? And this is the option for X4. X1 is red. X2 is 3 yellow. X3 is again red. Then there are 2 options because this is repeating X1 here. That's why 2 options. If these all are different, definitely here you will get only one option. That is this one you get. 1, 2, 3. Here definitely one option. If one of the color it is repeating here, definitely we will get 2 options. One is 2 and one is 3. Just see this particular path. X1 is 1. X1 is 1 means red. X2 is 3. X2 is 3 means yellow. This one is red and this is yellow. Then see here X3. X3 is 2. X3 is 2. That means 1, 3, 2 we used. 1, 3, 2. Then there is only one option for us for X4 is 3. Why? Because is here I use the option as red. Here I use the option as red. Here I use the option as yellow. Here I use the option as green. Definitely I can't use green here because it is adjacent. I can't use red. Then I can use only one color, is none other than yellow. That is why see here, if all the colors are different, we are filling for 3 vertices. 1, 3, 2. For all the 3 vertices we use a different color. Then there is no doubt the last vertex we will get only one option. That only I previously also I said. You see here X1 is 1, X2 is 3. 2 different colors it is used for X1 vertex, X2 vertex, or 1 and 2 vertex. For you see here for the third vertex we use the same color which was used for the first one. That is why 1 and 1. Then we will get 2 options because one color we saved here is repeating. Then we will get 2 options. That's it. And do not try to by heart this 1, 2, 3. Definitely you are going to get confused. That is why I will explain one more part here and clearly how to do. Once again I will explain. See here X1 is 1, whole tree is over. Now next X1 is equal to 2. Instead of red I am using green to fill this one. Because again repeating, adjacent vertices should not have the same color. Here I am giving as green. Then for the X2 I can have 2 options. One is green and yellow. That's why it is showing here 1 and 3. This particular one. Normally if you want to write here 1 and 3, it's okay because in the textbook it will write that color in the edge side. That's it. See here. Now again we have to start with the 2, 1. That time if you want, you can write here as 2 and here 1, and which color I can use it here. Correct? Like that, if you are drawing above that particular graph using pencil, and if you are solving, it will be good, right? And this one you should have a good practice, then only you can solve it fastly in the examination. Otherwise it is very difficult, right? Now see here, x1 is 2, x2 is 1. This particular path I am taking, always have to take from the root. Now x3, which are the option? I used only 2 and 1. 2 is here and 1 is here. Definitely again 2 I can use, right? And I can use 3 also. That means green and yellow I can use. Just see this particular path also. x1 I am using 2, x2 I am using 1, x3 I am using 2. That means the color it is repeating 2 times. Then definitely for x4 I will get 2 options. One is 1 and 3, and so on. Like this it is drawn. Please solve it and understand it clearly. Right? Thank you. Thank you very much to all my students.